Hi everyone, today I am going to explain to you on how to apply extrapolation to numerical integration. Let's say you have this integral 0 to pi over 2 cos x dx. And the questions say find the best approximation to the integral 0 pi over 2 cos x dx. Okay, so how do we know actually what formula to use? Okay, so the key point here is best. Best here refer to extrapolation. Now extrapolation, if you apply it to numerical integration, you call it, does anybody know? Romberg integration. Okay, so the best approximation here refer to Romberg integration. Okay, the word Romberg integration is derived using trapezoidal rule for n sub-interval. Okay, so obviously we are going to focus on trapezoidal rule for n sub-interval, which is also known as composite trapezoidal rule. So this is the how you know whether it's extrapolation or not. The key word here is the best approximation. So if you look at the extrapolation table, you have your interval start with h over 1. Let me put it 1 here. H over 2 and h over 4. So what does 1, 2, 4 here means? 1 here means n equals to 1. N here 2 means n equals to 2. Now n4 is n equals to 4. Okay, I hope you are clear with that. And now the first column here is my T11, T21, T31. Now how are you going to find all this T11, T21, T31? You use trapezoidal rule. Okay, now the rest is my T21, T22, T32, and T33. This is the best approximation. Obviously, you can go more. Okay, when I say more means you can go up to T44. But I just want to show you up to n equals to 4 interval. Okay, so you are given, this is what you're given. You're given an 0 to pi over 2 and your function is cos x dx. So this 0 is my a, pi over 2 is my b, and cos x is my function of x. Okay, with all this information you have gathered, now you have to divide the interval. Let's start with n equals to 1. Okay, so for n equals to 1, h. Okay, so I have T11, which is referred to T1, n equals 1. So the trapezoidal for, so we have b minus a, f of a plus f of b divided by 2. Okay, so this is for n equals to 1. So what it means here, it means that you have interval which is just 1. Okay, so this is your interval where this is my x0, x0 is my a and x1 is b, and a is 0, the given limit is 0. See, a is 0 here, and b is pi over 2. So since you have that, now you can just substitute. So T11, which is my T1, equals to pi over 2 minus 0. Function here is cos 0, which are a is 0, so cos 0 plus cos pi over 2 divided by 2. Okay, so cos 0 is 1 and cos pi over 2 is 0. So pi over 2 divided by 2, we have pi over 4, 1 minus 0. So I have pi over 4 for T1. Now you can simplify this by giving to few decimal places. So I'm going to give it to 0.785398. So use any calculator or any MATLAB to evaluate this. Okay, that's my T11. Now we got to look at, if you look at the diagram that I sketched, the second is, for n is 2. N is 2 and the third one is n is 4. So to find T21, so let's move on. So for n is 2, so we have T21, we have 2 interval. Okay, now you look at the composite trapezoidal rule for n subinterval, okay, which is given by h over 2 f of x naught plus 2 times f of x1 plus f of x2. Okay, this is for n equals to 2. So to understand this, I will encourage you to sketch the graph. I mean, not the graph actually. Sketch the interval or plot the n interval. So now I'm dividing into 2. So this is A, which is 0, and B, which is pi over 2. Pi over 2 divided by 2, I have pi over 4. So means my h from here to here is pi over 4. That's my h. Okay, so what you need to find the answer here, you need to find what is cos 0. This is cos pi over 4 and this is cos pi over 2. The other thing is, this is my x0, x1, x2. Okay, if you have that in your mind, then you can find T2 equals to pi over 4 divided by 2 f of x0, which is cos 0, plus 2 times cos pi over 4, okay, x1, which is this one, and then cos pi over 2. Okay, so now you have to use your calculator, where I have pi over 8, cos 0 is 1, 2 times cos pi over 4. So use any MATLAB to evaluate this, or calculator. Pi over 4 is 0.707107 and cos pi over 2 is 0. So using your calculator, that should give you 0.948060. Okay, that's my n2, and the next n is 4. Okay, so to find T31 for n equals to 4, this is my T4 in a way. So you are dividing the interval into 4 sub-intervals. So you have your trapezoidal rule formula as f of x0 plus 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus f of x4. Okay, so let's sketch the diagram for n equals to 4, where I have, okay, so I have 1, 2, 3, 4. So I have 0, pi over 2, pi over 4, pi over 8, 3 pi over 8. Okay, so remember, it's very easy if you can sketch it. So this is my x0, x1, x2, x3, and x4. Okay, so now I have my h here is from 0 to here. This is my h. This is my h, which is pi over 8. So T31, which is T4, equals to pi over 8 divided by 2. So pi over 8 divided by 2. I have f of x naught cos 0 plus 2 times cos x1, which is pi over 8, plus 2 times cos pi over 4, plus 2 times cos 3 pi over 8, and plus cos pi over 2. Okay, 2 is just for this, and this interval. x1, x2, x3, make sure you multiply by 2 in the front. Okay, so using your calculator, you will have your T4, your T31 is equals to pi over 16. Cos 0 is 1. 2 times cos pi over 8. 2 times 0.923880 plus 2 times cos pi over 4, which is 0.707107 plus 2 times 3 pi over 8, which is 0.382683, and lastly pi over 2 is 0. So using your calculator, you should end up with 0.987116. Okay, so we are close to solving now. So what happened? We have obtained T, the table, the experimentation. So now you want to find is T22. So T22, so this is what you got to find. You have obtained all this value here. So T11, so you obtain this value, you have obtained this value, you have obtained this value. So T22 will be 4 times T21 minus T11 divided by 3. And T22 is also equals by 4 times T31 minus T21 divided by 3. And T33 equals to 16 times T32 minus T22 divided by 15. Okay, so by having that, you can simplify your calculation. So let me write again. So T22 equals to 4 times T21 minus T11 divided by 3. I already obtained this earlier on. I'm just going to write to you the calculation answer. And then to find T32 is 4 times 3T1 minus T21 divided by 3, 1.00135. And then lastly, our best approximation, T33, is obtained by, now if this is order 2 to the power of 2, this one will be 2 to the power of 4. Okay, so which will be T32 minus T22 divided by 2 to the power of 4 minus 1. So I have 16 T32 minus T22 divided by 15. So you have obtained 32 and 22, which is this. So multiply 16 times this minus this divided by 15. That will give you the best approximation, 0.999992. Okay, so this is how you perform Romberg integration for numerical integration. Okay, Romberg integration. So remember, I just want to recall quickly in case you forgot how to do it. If this is order P is 2, okay, so this one will be P is 4. So your extrapolation formula is 2 to the power P T H over 2 minus T H divided by 2 to the power P minus 1. Depends on what H you are using here. Okay, that's all. Thank you. Bye.